Hello everyone, welcome to Brain Blitz Audios. Today, in this episode of NEET preparation, we'll be looking at previous year questions of physics in medical engineering examinations in India. Today we're dealing with the chapter Electromagnetic Waves. This is the 8th chapter in the grade 12 syllabus for physics in CBSE. Electromagnetic waves is a short chapter dealing with displacement current and the electromagnetic spectrum. Let's begin with our first question. According to Maxwell's hypothesis, changing of electric field gives rise to magnetic field, pressure gradient, charge, voltage. Which of these is the right option? When we look at Maxwell's hypothesis, we will understand that in a capacitor, there is the flow of electric field, and this is constantly changing, and when there is a change in this electric field, there is current produced, which is displacement current. And when they measured for a magnetic field, they noticed that a magnetic field which is concentric, similar to the ones found on a straight current carrying conductor, is found between the plates of a capacitor. So therefore, according to Maxwell's hypothesis, the changing of electric field gives rise to displacement current, and this displacement current gives rise to a magnetic field. So therefore, option A, magnetic field, is the right option. Let's move on to our next question. The frequency of infrared wave is approximately 10 raised to 18, 10 raised to 14, 10 raised to 9, 10 raised to 16 hertz. So we could use an electromagnetic spectrum and then find out the frequency. However, let's solve this question. Now, infrared waves are the rays which have higher wavelength than red light. So these are just above light. So if red light has a wavelength of 7,000 angstroms, then infrared rays will have a wavelength greater than 7,000 angstroms. So what we'll do is let's consider the lambda or wavelength of an infrared wave be 7,000 angstroms, or approximately 7,000 angstroms. Now, we use the formula to find frequency. Frequency is equal to speed of light divided by the wavelength. Nu is equal to c divided by lambda. C is the speed of light, which is 3 into 10 raised to 8, divided by lambda is 7,000 angstroms. So that is basically 7,000 into 10 raised to minus 10, which we can write as 7 into 10 raised to minus 7. So now we can write this down as 3 by 7 into 10 raised to minus 7 goes up, so that becomes plus 7. 8 plus 7 is 15. 3 by 7 into 10 raised to 15. Let's start calculating. So again, let's write it down. The frequency nu is equal to 3 by 7 into 10 raised to 15. 3 divided by 7. 0 point, add a 0. 7 times 4 is 28. That is the closest to 30. Subtract that, you get 2. Add another 0, you get 20. 7 times 2 is 14. You get a balance of 6. Add another 0. So that's 60. 7 times 8 is 56. So you get a 4. Add another 0. So you get 5. So 7 times 5 is 35. 40 minus 35 becomes 5. So that's more than enough. So let's take this highly precise value as the answer. Mu is equal to 0.4285 into 10 raised to 15. But if you look at this value, this is not exactly in the form of scientific notation. In scientific notation, the same value will be equal to 4.285 into 10 raised to 14. So you multiplied it by 10. So this is the value of the frequency of infrared light. So infrared radiation has a minimum frequency of 4.285 into 10 raised to 14. Now you don't need to worry too much about the numerical value of the scientific notation. It's just the power of 10 that we need to focus on. That is 10 raised to 14. So infrared radiation is in the order of 10 raised to 14. And which of these options has 10 raised to 14? Option B. So therefore, option B, 10 raised to 14, is the right answer. So if we look at 10 raised to 18, that is somewhere in the middle, and we're asking about the starting frequency of the infrared wave. 10 raised to 9 means that you have dropped further. We've dropped further into about radio waves, so that is incorrect. 10 raised to 16 is close enough to ultraviolet, so that's incorrect. And 10 raised to 18, we've reached the realm of X-rays, so option A is incorrect. So this is with respect to frequency. So with respect to frequency, 10 raised to 14 is the order for the frequency of infrared wave. Option B is the right option. Let's look at our next question. Which wavelength of sun is used finally as electric energy? So if we look at our given options, radio waves are used for communication. Visible light is also used for communication, because without light we cannot see, gathering information. Microwaves, they are used for navigation, the radars, and also cooking. Microwaves. So all of these are incorrect. The right answer is option B, infrared waves. Infrared waves have a characteristic heating property, and that's why we use IR from the sun in order to warm our cells. And this heating property again can be used in solar heaters and also solar cells. So therefore, solar cells convert the energy from the sun into electricity. So therefore, infrared waves are the wavelength of sun, which we use finally as electric energy. So option B again is the right option. Next question. If the magnetic field of a light wave oscillates parallel to the y-axis and it is given by the equation By is equal to Bm times sine of kz minus omega t, the direction of wave travel and the axis along which the electric vector oscillates is. Here we're asked to find out two quantities using the equation By is equal to Bm times sine of kz minus omega t. Let's look at that equation in some detail. Bm times sine kz minus omega t. So over here, we know that By means that the magnetic field is along the y-axis, and the magnetic field of a light wave oscillates parallel to y-axis. But if we look at the sine function, you see a component kz. So that alone should show you that the direction of propagation of light is along the z-axis. And since magnetic field is flowing along the magnetic field is going along the y-axis. The light ray is flow along the z-axis. So therefore, along the x-axis, the electric vector flows, because in electromagnetic waves, the electric component and magnetic component, the electric and magnetic fields, are both perpendicular to each other and also perpendicular to the direction of propagation of the wave. So therefore, the electric vector has to be along x-axis, and the direction of light has to be along z-axis. So therefore, the right option will be option B, negative z-axis and x-axis. It doesn't matter whether it's negative or positive. Both directions will always be perpendicular to both the x and y axes. And if you look at the other options, it says that wave travel is along y-axis, which is incorrect. And here in both C and D, it says along negative x-axis the wave travels, but however, that is against the component that we get in By is equal to Bm sine kz minus omega t. So options C and D are incorrect. The right answer is option B. The direction of wave travel is along negative z-axis, and the axis along which the electric vector oscillates is along the x-axis. Next question. The energy of electromagnetic wave in vacuum is given by the relation. And we have 4 relations given here. So, how do you calculate the energy of an electromagnetic wave? Well, it has 2 components. Electric energy density and magnetic energy density. So, the energy of an electromagnetic wave is the sum of electric energy density and magnetic energy density. So, electric energy density is having the formula half times epsilon naught times E naught square. And the formula for magnetic energy density is equal to B square divided by 2 mu naught. So therefore, the total energy of an electromagnetic wave is equal to half into epsilon naught times E square plus B square divided by 2 mu naught. And this equation is the same as option D, so it is the right option. All the other options are incorrect. In option A, the electric component is incorrect. In option B, the magnetic component is incorrect. In option C, both components are incorrect. And in option D, we have the correct components given. Energy of an electromagnetic wave is half epsilon naught E square plus B square divided by 2 mu naught. Next question. Which of the following are not electromagnetic waves? Is it A, cosmic rays, B, gamma rays, C, beta rays, or D, X-rays? Well, let's look at an electromagnetic spectrum in order to clear this question. Option A, cosmic rays. Cosmic rays range under the frequency of 10 raised to 24, so these are high energy electromagnetic radiation, almost on the border between electromagnetic and non-electromagnetic wave. So option A is incorrect because cosmic waves are a part of the electromagnetic spectrum. Next, we have therapy waves. Therapy rays are also known as gamma rays because gamma rays are what we usually use in order for cancer therapy, and that's why they're called therapy rays. They are in the order of 10 raised to 22. So option B is also incorrect. Gamma rays are a part of electromagnetic spectrum. The next is X-rays. So if you can see, it's in the order from 10 raised to 20 to 10 raised to 17. And these X-rays are used for radiography. So therefore, option D, X-rays, is also incorrect. All three of these are part of the electromagnetic spectrum. So cosmic rays, gamma rays, and X-rays, they're all electromagnetic waves. The only one which is not is option C, beta rays. So what is beta radiation? Beta radiation is actually a beam of fast moving electrons. So beta radiation is a beam of fast moving electrons, so therefore they're not a part of the electromagnetic spectrum, which is just radiation. Option C is the right option. Now let's look at this question. Light wave is traveling along y direction. If the corresponding E vector, which is the vector for electric field at any time, is along the x-axis, the direction of the magnetic field vector at that time will be along. So let's look at this question. It has a diagram which is now attached. So we have light waves traveling here. We have electric field traveling here. And the postulate is that the electric and magnetic fields created by the EM wave is A, perpendicular to each other, and B, perpendicular to the direction of the wave. So the direction of propagation of wave will also be perpendicular to both these quantities. So over here, the wave is propagating along the y-axis and the electric field is along the x-axis. So the only other axis which is mutually perpendicular to both these axes is the z-axis. So therefore, magnetic field must go along the z-axis, and we can put that as plus z. So option C, plus z-axis, is the right option. So it's going along positive x, and it's going along positive y. So therefore, the resultant should go along positive z. So in order for it to make an electromagnetic wave. So option C, z-axis plus z-axis, is the right option. So now we've reached the final question. Electromagnetic wave consists of periodically oscillating electric and magnetic vectors, and here we have 4 options regarding the plane of the motion of electromagnetic wave and also the phase difference. So now, in order to solve this question, let's have an image of an electromagnetic wave in action. So as you can see, this is how an electromagnetic wave propagates. Let's look at each of our options. In option A, it says that periodically oscillating electric and magnetic vectors are in mutually perpendicular planes. That is correct, but vibrating with a phase difference of pi. If you see, when the electric field increases, the magnetic field also increases, and as the electric field approaches 0, the magnetic field also approaches 0. So therefore, option A is incorrect. There is no phase difference. What about option B? Mutually perpendicular planes, that is correct. Vibrating with a phase difference of pi by 2, again incorrect. There is no phase difference. In option C, it says randomly oriented planes but vibrating in phase. This is correct, but this statement is incorrect because if you notice, electric field and magnetic field, they are perpendicular to each other. So therefore, they're not randomly oriented. So option C is incorrect. The right answer, which captures this motion of an electromagnetic wave, is in mutually perpendicular planes, and vibrating in phase. Option D is the right option. And that concludes this video on electromagnetic waves. If you like what you saw, then don't forget to comment in the comment section down below. If you want to have access to more of our content regarding NEET preparation, then don't forget to click the link in the description down below. For more useful and interesting content, don't forget to subscribe to our channel, Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.